Download this code from codegive.com, link in the description below. The problem: maximum sum of 3 non-overlapping subarrays, leetcode 689, is an interesting challenge that requires a strategic approach to efficiently find the maximum sum of 3 non-overlapping subarrays of a given size. Here's a detailed tutorial on how to approach this problem. Problem statement. You are given an integer array nums and 3 integers len1, len2, and len3. The task is to find 3 non-overlapping subarrays of lengths len1, len2, and len3, respectively, such that their combined sum is maximized. Constraints. The lengths of the subarrays, len1, len2, len3, must be non-negative integers. The sum of len1, len2, and len3 must be less than or equal to the length of nums. Approach. 1. Prefix sum array. Compute a prefix sum array to facilitate quick calculation of the sum of any subarray. The prefix sum at index I will contain the sum of all elements from the start of the array up to index I. 2. Calculate subarray sums. Pre-compute the sums of all possible subarrays of lengths len1, len2, and len3 using the prefix sum array. 3. Dynamic programming. Use dynamic programming to keep track of the maximum sums of the first 2 non-overlapping subarrays up to each index. 4. Iterate and compute maximum. For the third subarray, iterate through the possible starting positions, and for each position, check the maximum combined sum of the first 2 subarrays. Code example. Here's a Python implementation of the above approach. Explanation of the code. 1. Prefix sum calculation. The prefix underscore sum array is computed to allow 1. Time complexity for calculating any subarray sum. 2. Max sum arrays. Max underscore sum 1 keeps track of the maximum sum of the first subarray that can end at each index. Max underscore sum 2 maintains the maximum sum of the first 2 non-overlapping subarrays. 3. Final calculation. Finally, we iterate over possible starting positions for the third subarray and check the maximum sum we can achieve by adding it to the best combination of the first 2 subarrays. Complexity analysis. Time complexity, n, where n is the length of the nums array. This is due to the single pass needed to compute the prefix sums and the subsequent passes to compute the max sums. Space complexity, n, for storing the prefix sums and the max sums. This approach efficiently finds the maximum sum of 3 non-overlapping subarrays while ensuring that the solution is optimal and scalable.